Okay, so question five. Question five is a nice question. It's trying to trick you into thinking this is the trolley, the ramp, and velocities and speeds and accelerations, and it isn't. So it's one of you might have seen this in your exams where I write read the question. So let's make sure you read it carefully. It says when the button's pressed, there's the button. A spring in P is released. So I'm thinking to myself, right, there's a squashed up spring ready to ping that trolley up the track. The trolley travels up the track and stops. So this is going to go here and say go to a point. And then it's going to roll back down. Okay, fine. So pretty happy with all that. The spring in P always exerts the same force. So the spring is a control variable when projecting the trolley. A student investigates how the mass of the trolley, so there we go. So that is so I'm just going to write over here. So the mass is the independent variable, the thing we're changing, and how this affects the maximum vertical height, h. Okay. And they've been really clear to you to say it's the vertical height. So they're interested in this, not, if I change my colour now, hello colour, they're not interested in the length along the track. Okay, so just be super careful there. We've got to then talk about how are we going to measure that maximum height. So if I just change my colour back, where's that nice blue gone? There. State the measurements the students to make to complete the investigation. You should make use of the equipment shown. There we go. And any other equipment that's needed. So the crucial part now then is it tells us what we've got to change. So let's just go through. Mass is the independent variable, and we've said maximum vertical height is going to be the dependent variable. So crucially, I'm going to have to change the mass, and I'm going to say that to the examiner. I'm then going to just randomly pick some masses to have at least 5 results in my range. And the reason for that, we always have at least 5 in our range. You can imagine if I've got 2 points, I don't know if that is a pattern or whether one of them's wrong. If I've got 3, I definitely can't tell the pattern there. If I've got 4, yep, still not quite got the pattern. Now if I've got 5, 6, 7, I can then see, yeah, that's the pattern and you're an outlier. So always have at least 5 results in your range. And then we're ready to go. So ultimately it's tell the examiner what you're changing, pick some values for them to change, say what you're going to measure, say how you're going to measure it. So our very first part is we're going to change the mass of the trolley. One mark. I'm now going to just pick some random masses. For example, e.g. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, add an extra one just because I can, 0.7 kilograms. The mass done, 2 marks. So the next part is going to come up with a way now to make sure I'm always doing the same thing. So I'm going to say that I'm going to, as that goes up, I'm going to mark with an X on the track where the front of the trolley gets to, and then I'm going to measure that with a ruler. Because there's going to be a mark for that. So it's then when trolley stops, mark an X on the track where the front of the trolley reaches. Next part, use a ruler to measure, and I'm just going to use a H here, largely because it tells me that I can use H in the diagram. Next part, and then the last part, which is always good to have an investigation, and then we're going to repeat 3 times for each mass, 4 marks. Okay, next one. Figure 6 is a graph of the student's results, so we can see that there, and it says the student states that the energy transferred by the spring is the same each time it is used. Use data points from 2 points of graph to support this statement. So you've got to have a little bit of understanding of here. We've got to know, well, we've got elastic potential energy in the spring. All right, and if I wanted to calculate it, I could use half kx squared, and that's going to be transferred to GPE, and that's going to be transferred to mgh, and you could have guessed this anyway, because you can see mass there height there. So you could have gone into your formula book to say, well, which one has a mass and a height? And you see, well, it's this one, GP equals mgh. So now we're ready to do some calculations. And a nice thing to do is, well, I'll pick a point here. Done. I'm going to pick 0.6, pick the first point in the graph. And I'm going to pick here with 1. And I'm going to use those two to prove that they're the same. So if I look at that value there, I know that at 0.60 for the x value, the height is 0.23. You can see that there where it crosses. And for this one here at 1.00, it's got to, I think each of these is 0.2. Let's double check. Yep. So put 1, 3, 1, 2, 1, 4, 1, 6, 1, 8. So 0.138. I'm just going to double check to make sure I've got that right. Yep, that's working out for me. And now I can put that into the formula. So just expand that. GPE equals mgh at 0.6 on the x-axis. I can say that that's 0.6 times gravity 10 times the height 0.23 equals 1.38 joules, so roughly 1.4. If I now do it at 1.0 on the x-axis, use our values that we had from there. So, well, that looks like a 6. Let's change it to 0. So 0.138 equals 1.0 times 10 times 0.138 equals 1.38 joules, which is approximately 1.4. And there we go. QED. Okay, so what does that mean? That which has been demonstrated, used in maths to just say, look, I've demonstrated what you've asked me to demonstrate. So QED, those results are the same. Done. Next part, it says, describe how the student could extend the investigation to determine the average speed of the trolley as it rolls back down. Really easy question this now. So, well, we know, shoot Donald Trump. I'm going to have to change that now with all the modern things. So I'm going to have to pick a new memory method. So we can say, well, speed equals distance divided by time. That's going to get us a mark. And now we've just got to describe how we'd do it. Use a ruler and measure a set distance on the track, and then use a stop clock to measure the time to travel the distance. And then the last part is, use what I've said above, use S equals d over t to calculate the speed. And there we go, that's question 5 done. Quite an easy question, but it really does take you to picture the practical and imagine it in your head.